Children, today we are going to discuss about conservation laws. Laws such as law conservation of linear momentum, angular momentum, energy, charges. These are the law of conservation. These are the basic or fundamental laws in physics. Basic or fundamental laws that comes in physics. These laws we can observe and also experimentally we can verify this, but we cannot prove these laws. That means conservation laws are fundamental laws. These we can observe and also can find out through experiment, but we cannot prove it through experimentally. These laws cannot be proved by experimentally. It cannot prove through experiment. But if in any situation, if an experiment is against this, shows a result against this one, then this laws is not applicable. But in that case, that means if in any experiment, if it is not satisfied along with this, then that law is not, we cannot consider as law conservation. Which are the conservation laws in physics? Law conservation of linear momentum, angular momentum, energy and charges. Now from this unit we discussed about first law of motion, second law of motion and Newton's third law of motion, and also law conservation of linear momentum. Now we are going to discuss about some textual questions here given. See, the first question is this one. If action is always equal to the reaction, explain how a horse can pull a cart. Once again, if action is always equal to the reaction, explain how a horse can pull a cart. We know action equal to a reaction, but they are opposite, but they are not acting on the same body. Action and reaction equal and opposite, but they are not acting on the same body. Because of that, they will not cancel each other. Here, to move the cart, horse exert a force on the ground. Horse exert a force on the ground in the backward. Then the ground exerting an equal force on the horse. Because of that, it can move forward. Because of that, it can move forward. That is horse exerting a force on the ground in the downward direction. Then the ground exert a force in the opposite, and it is in the forward, so it moves in that way. And second question, explain why is it difficult for a fireman to hold a hose which ejects large amount of water at a high velocity. Once again question, explain why is it difficult for a fireman to hold a hose which ejects a large amount of water at a high velocity. See here, water from the hose coming forward with a very high momentum. High forward momentum. water is coming through the hose, it exert, that means water from the hose when coming forward, there is a very high forward momentum. That means then the hose exerted, that means that water exert an equal momentum in the backward direction. Then the water exert an equal momentum on the hose in the backward direction. That means when the water is pushing forward, there is a very great momentum in the forward direction. Then the water exert a very great momentum on the hose in the backward direction. So the fireman, when it hold it, he find it difficult because of that backward momentum. Because of that backward momentum, he cannot hold that hose. That is, he feel difficult. That is why he feel difficult. Here, two momentum is one water pushing forward, that is coming out forward with a great momentum. Then the water exert equal momentum in the backward on the hose. So the fireman find it difficult to hold it. Then another question. From a rifle of mass 4 kg, a bullet of mass 50 gram is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the rifle. See, the problem here given is from a rifle of mass 4 kg. That first of all given mass of a rifle. Let it be M1 is equal to 4 kg. Now, a bullet of mass 50 gram, mass of the bullet is equal to 50 gram. That to change 50 gram to kilogram, which is a SI unit, we want to divide with 1000, so this become 0.05 kg. And the bullet is coming with a velocity of, that means the velocity of the bullet, let it be V1, is equal to 35 meter per second. 35 meter per second. Then calculate the initial recoil velocity, that means a recoil velocity of the, this we can take as a V2 and let V1 be the recoil velocity. V1 be the recoil velocity. See, mass of the rifle we take as a M1, that is 4 kg. Mass of the bullet, that is 50 gram, is equal to 0.05 kg. You know how to convert this gram into kilogram by dividing with 1000. Let velocity of the bullet, let it be V2 is equal to 35. V1 be the velocity of the gun, that is recoil velocity. That means momentum before firing is equal to momentum after firing. Before firing, that means a gun were at rest and also bullet were at rest. And after firing, we know they are moving. So momentum after firing, that is equal to M1 V1. That means momentum of the gun plus M2 V2. Momentum of the bullet is equal to momentum before firing, that is equal to 0. This M1 is the momentum, M1 V1 is the momentum of the gun, M2 V2 is the momentum of the bullet. These two are after firing is equal to before firing. That is M1 is 4 into V1, that we don't know, V1 plus M2, that is 0.05 into V2, 35. See, 4 into V1 into this relation. Now, we can want to find out this V1. So, 4 V1 is equal to, this quantity we can shift it to other side. That is equal to minus these two will multiply, that is 35 into 5. 5 times 5, 25. 5 times 3, 15 plus 2, 17. That is equal to 175. Here 2 decimal that we want to put. That is equal to 1.75. 1.75. When we multiply this one, we get what is 5 times 5, 25. Then balance 2, 5 times 3, 15 plus 2, 17. And then put a 2 decimal. Now V1 is equal to minus 1.75 divided by 4. You know how to divide this one? Then how much this will come? That is 1.75 divided by 4. We cannot take 4 from 1, so we put a decimal at first. Now 17, that means 4. That means 16. 1, 5. That means 4 times 3. 12. 3. 30. That is equal to 7. So this will come as how much? Minus 0.437 meter per second. Meter per second. So this is the velocity with which the gun moves. Here the negative sign shows. Here the negative sign shows gun moves opposite to the bullet. So it is called a recoil velocity. That means it is moving in the opposite direction. Recoil velocity. That is it moving in the opposite direction. Now another problem here given is. See next one. Two objects of masses 100 gram and 200 gram are moving along the same line and direction with velocities 2 meter per second and 1 meter per second. Two objects, suppose these two are moving along the same line. See, first one mass is 100 gram. And second one mass is 200 gram. This we can take as a bit bigger one because its mass is small. And they are moving along the same line and direction with the velocity. The velocity of this one 2 meter per second and this one is 1 meter per second. See, respectively, they collide after the collision. First object moves with a velocity of 1.67 meter per second. Then determine the velocity of the second. See here, two objects. First one mass 100 gram moving with a 2 meter per second and second one mass 200 gram moving with a speed 1 meter per second. They two collide and after the collision the speed of the first one is 1.61 meter per and this one is we want to find out. Let the mass of the first one M1 that is 100 gram. That we can change to kilogram by dividing with 1000. So it will come as 0.1 kg, 0.1 kg. Then second one and its velocity, let it be that we can take as V1 or we can take as U1, its initial speed. That is U1 is equal to 2 meter per second. And second one mass M2. Mass of the second one M2 is equal to 200 gram. That is equal to 200 gram. That way when we change to kilogram, how much it will come? 0.2 kg. It will come as 0.2 kg. And its velocity U2 is equal to it is given as 1 meter per second. Now these two collide, and after collision, velocity of this one, that is v1 is equal to 1.67 meter per second. That means velocity of the first one. And we want to find the velocity of the second one, that is v2 is equal to how much? That we want to find out. Okay, see here mass of the first object is 100 gram. When we change to kilogram, it becomes 0.1, and its velocity u is equal to 2 meter per second, m2 is equal to similarly 0.2 kg, u2 here given 1 meter per second, v1 is equal to 1.67 meter per given, and v2 we want to find out. See, we know momentum before collision is equal to momentum after collision. Momentum before collision is equal to momentum after collision. That is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. See, m1 is 0.1 into u1, that is 2 meter per second, plus m2 is that is given as 0.2 kg, and its speed is 1 meter per second. And speed of after collision, first one is and the mass is 0.1 into 1.67 plus mass of second one is 0. Into its speed is v2. Now we can multiply. This one multiply, we get as 0.2 plus 0.2 into 1, that also 0.2 is equal to these two. When multiply, it will come as 0. That means 1 with 1 when we multiply, the same value will come, and 1 decimal also we want to put. So here 2 and here 1 3 decimal plus this 0.2 v2. Now adding these two, we get 0.4 is equal to 0.167 plus this is 0.2 v2. Now for simplification, we see 0.4, this plus quantity when we bring this side, it becomes minus 0.167 plus here 0.2 v2. Now we can subtract this one. When we subtract it, see what we will get from 0.4, 0.167. What we can take to here 10 minus 7 3 from 9 6 3. Here 1 is taken. Remaining is 3. 3 minus 1 2. See. Now v2 is equal, that is equal, this will come as 0.233 is equal to 0. Here equal to, that means when we put this on here, it become equal to, that means 0.4 minus 0.167, that means here it is equal. So here 2 v2 or v2 is equal to, from this 0.233 divided by 0.2. We want to divide this one. We can remove 1 decimal from up and down. Then what will get 2.33 divided by 2. That means here on decimal, moving to this side, here also on decimal. That means here 1 times 2, balance 0. In 3, how many times? 1 times 2, so 1. Balance 1 and 3, 6. So V2 is equal to, how much will come? 1.16 meter per second. With this speed, the second body moves. With this speed, the second body moves. Okay, now see, these are the questions given there. Now, here given some exercise. We can answer that also. First question, an object experiences a net zero external unbalanced force. Is it possible for the object to be traveling with a non-zero velocity if S state the condition that must be placed on the magnitude and direction of the velocity, if no, provide a reason. Question once again. An object experiences a net zero external unbalanced force. Net zero unbalanced force. External force. Net zero unbalanced external force. Is it possible for the object to be traveling with a non-zero velocity? If S, state the condition that must be placed on the magnitude and direction of velocity. If no, provide a reason. See, net zero unbalanced external force is acting. That means from second law, if net force is zero, that means F is equal to ma. That means if F is equal to 0, that means m is not 0. That means acceleration is 0. Acceleration is 0. That means that body is moving with uniform velocity. That means that body is moving with a uniform velocity. That means it is not accelerating. So by second law, if F is 0, that body is not accelerating. It means it is moving with the uniform velocity. From first law, by the law of inertia, if the body is moving with a uniform velocity, then it will move with a uniform velocity itself. That means a body moving along a straight line in uniform motion, that will continue. That is the condition. If the body were at rest, then it will be continue at rest. From this, what we can conclude? If the body were at rest, that will be at rest. If the body were moving with a uniform velocity, then that will move with a uniform velocity. That we can conclude from this. And the second question. When a carpet is beaten with a stick, dust come out of it. Explain. When a carpet is beaten with a stick, dust come out of it. Explain. See, carpet and dust, they were at rest before beating with a stick. So, they were at rest means carpet and dust, they were at rest. Here we can consider inertia of rest. But when the carpet is beaten with a stick, carpet moves, but the dust remains there at rest. Because of that, dust gets separated due to inertia of rest. Dust is separated from the carpet due to inertia of inertia of rest. Because of that, they were separated. Once again, before beating with a stick, carpet and dust were at rest. That means inertia of rest were both of them. But when we beaten with the stick, carpet moves, but the dust continues to be at rest due to inertia. So they were separated and dust fallen down due to that. And third question C. Why is it advised to tie any luggage kept on the roof of a bus with a rope? See, why is it advised to tie any luggage kept on the roof of a bus with a rope? We see, when the bus is moving, due to inertia, when it is speed up or it's speed down or change direction, due to the inertia, the luggage can be fallen down. That means when the bus is speeding up, due to inertia, the luggage can be move backward. And when it is speeded down, the luggage tries to move with the same speed as before. So it moves forward and can be fall down. When the direction of the bus changes due to inertia, it can be fall sideways. Because of that, we are advised to tie the luggage with a rope in order to in order to avoid it to fall down. And now this is fourth question. A batsman hit a cricket ball which then rolls on a level ground. After covering a short distance, the ball comes to rest. The ball slows to a speed because the answer there given is C. There is a force on the ball opposing the motion. There is a force on the ball which opposes the motion of the ball. Because of that, it comes to rest. Now, question number 5. Question number 5. A truck starts from rest and rolls down a hill with a constant acceleration. It travels at a distance 4 meters in 20 seconds. See, a truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meters. 400 meters in 20 seconds. In 20 seconds. 400 meters in 20 seconds. Find its acceleration. Find the force acting on it. Find its acceleration. Find the force acting on it. If the mass of the truck is given as 7 tons, that means M is given 7 tons. That means 1 ton is 1000 kg, so it is 7000 kg. Now, the truck starts from rest, so its initial speed u is equal to 0. Now, what are the things given? Now, we want to find out acceleration. See, u is equal to 0, s equal to 400 meter. T is given A, we want to find out. See, from this relation, F is equal to MA. That means which relation we can use? That means S equal to UT plus half A T square. From this we get this A. The relation we know, yes, that means displacement is equal to initial velocity time this. Here S is given as 400 is equal to U is 0 into T 20 plus half A, that is not given, into T 20 square. That is 400 is equal to, this terms into 0 means we can avoid. This will come as half into A into 20 square is 400. 20 square is 400. This 400 when we divide with 2, once again 400 is equal to, with this 2, what will get 200A. That means this quantity, when we divide with this 2, this 400 become 200 and A, 200A. From this we can find out A. See, A is equal to 400 divided by 200. A is 400. Therefore, A is equal to how much? That means 400 divided by 200. That is equal to 2 meter per second. 2 meter per second. Now, what we want to find out again? We want to find out the force also. We want to find out the force also. We know force F is equal to, from Newton's second law, F is equal to ma. F is equal to ma. That is m is 7,000 into A is 2. That is equal to 7 into 2, 14 and 3, 0. That means this much Newton, 14,000 Newton. This is the force acting. How much? 14,000 Newton is the force acting. Now, we can go to next question. See, question number 6. A stone of 1 kg is thrown with a velocity of 20 meter per second across a frozen surface of a lake and comes to rest after traveling a distance of 50 meter. What is the force of friction between the stone and the ice? See, a stone of mass of the stone is 1 kg. Mass of the stone is 1 kg. With a velocity of the stone is equal to 20 meter per second. 20 meter per second across a frozen surface of a lake and comes to rest after traveling a distance travel is equal to 50 meter. Then find the force acting. What is the force of friction between the stone and the ice? We want to find out. See here, the stone is thrown with a velocity that we can take as initial velocity u, 20 meter per second. Initial velocity and final velocity v is equal to 0 because the stone comes to rest 20 meter per second and 0 meter per second. Now, first of all, we want to find out acceleration. We can use this relation. 2as equal to b square minus u square. Here 2 into a, that we don't know. Yes, that means how long it travels? 50 meter. 50 is equal to b square. Final speed is 0. Square minus u it is 20 into 20 square. That means 2 into a into 50. That means 100 a is equal to, this will come as minus 400. This minus is not here. This 20 is a positive. So its square is 400. Minus 400. So a is equal to minus 400 divided by 100. It is equal to minus 4 meter per second square. This is the acceleration of that stone with a negative because it is in the opposite direction. That acceleration is opposite to the motion of the stone. Now what we want to find out? The force of friction. The force of friction, we know what is from second law. What is force of friction is the force acting on it. Hence, F is equal to, we know, ma. Mass is 1 kg. That means 1 into a is minus 4. That is equal to 1 into minus 4 is minus 4 Newton. Here the force is minus getting, so the frictional force is 4 Newton. Here the force acting on it is minus 4 Newton, means this force is opposite to the direction of motion of the stone. This force is opposite to the direction of motion of the stone, hence the negative sign coming. If we consider friction, then it is 4 Newton. The friction acting on it is 4 Newton. Now question number 7th one. A 8000 kg engine pulls a train of 5 wagons, each of 20 kg, 2000 kg. 5 wagons, each wagon of 2000 kg. Each wagon of mass 2000 kg. Along a horizontal track, if the engine exerts a force of, the force exerted by the engine is how much? It is given as 40,000 Newton. 40,000 Newton. And the track offers a friction of 5,000 Newton. The friction offered by the track is 5,000 Newton. Then calculate first the net force acting. The net force acting is equal to total force exerted minus frictional force. That is a net force. That is question number 7th on. First of all, we want to find out the net force. Net force equal to force exerted by the engine minus force exerted by the friction. So force exerted by the engine is how much? 40,000 minus friction is 5,000. That is equal to 35,000 Newton is the net force. Net force is 35,000. And second question, the acceleration of the train. We know acceleration is equal to, that means F is equal, from second law, F is equal to ma. We want to find out acceleration. From this relation, acceleration A is equal to what will get? F by m. That is equal to F here 35,000 divided by m. M means mass of the 5 wagons. Mass of one wagon is 2000 kg. In that way 5 wagons comes, it has 10,000. See, mass of 5 wagons we want to consider. That means each wagon with 2000. Each wagon with 2000. So we get 2000 into 5, that is equal to 10,000. 35,000 by 10. We can cancel this 30. Then 35 by 10. To divide with the 10, we want to give only one decimal point. That means 3.5. That means meter per second square. 3.5 meter per second square is the acceleration. 3.5 meter per second square is the acceleration. Now we got acceleration. Now, question C from this. The force of wagon first on wagon 2. Force on wagon first on 2. See, from the force on wagon first on second one. Means second one is pulling third one, fourth one and fifth one. So, the first wagon exerting force, second means it is connected with third, fourth and fifth. So the total mass of these 4 is how much? That means 2000. Another one is 2000. Next one is 2000. Third, fourth. This also 2000. And altogether mass is equal to how much? 8,000 kilogram. 8,000 kilogram. So force exerted by first wagon on second, F is equal to, that is m into A, that is equal to M is how much? 8,000 into A, 3.5 that is here given. When we multiply 8 with 3,000, how much it will come? 28,000. It will come as 28,000 Newton. Its value is how much? 28,000 Newton. This is the force exerted by the first wagon on the second wagon. Okay. Now we can go to the next one. See question number 8 one. An automobile vehicle has a mass of 1,500 kg. Mass of 1,500 kg. What must be the force between the vehicle and the road? If the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square. Once again the question. An automobile vehicle has a mass of 1,500 kg. What must be the force between the vehicle and the road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square? See, force F is equal to, from second law, Ma. Here mass is given into acceleration with negative. Now, when we multiply 17 into 15, how many times it will come? So 5 times 7, 35, minus 3, 5, 8. That is equal to 255 and 20. With here we want to give one decimal point and this negative sign also. So what will come? That is equal to minus 2,550 Newton, which is in the opposite direction. That is the force must be that much force must be applied there. That much force must be applied in this case. We want to do some more problems from this unit, but before that, what are the things we discussed here? We discussed about Newton's first law, second law, third law, and equation connecting them. That means which is the equation we took to solve problems? F is equal to ma, and law conservation of momentum. That means momentum before collision is equal to momentum after collision. So here F is equal to ma, one equation, and another equation m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, and conservation of momentum. With this all we can conclude today's class. Okay.